Hi there, I'm Alice Major, and I'd like to read you two poems today that are both inspired by the way that mathematicians will worry away at a problem until they finally find a proof of the answer. The first one's called Honeycomb Conjectures. Now, the Honeycomb Conjecture states that a regular hexagonal grid, like a honeycomb, lets you divide space into subsections in such a way that the total perimeter of all the sections is the shortest possible. Now, the conjecture was first actually recorded in 36 BC by the Roman scholar Terentius Marcus Varro. But he said that it was actually much older than his time. However, it was not proved until 2,000 years later, and it took a 20-page proof by the mathematician Thomas Hales to do so. Well, of course, the honeybees had solved it long before. And this poem is about how a bee mathematician might break it down. Honeycomb Conjectures. Hypothesis 1. Wax's fragile scaffold can bear the weight of pounds and pounds of sweetness. Hypothesis 2. Repetition is acceptable. Honeycomb, hexagon, we could tile the universe unending. Hypothesis 3. Wax's mathematics, 6 straight sides contain least wax, most honey. Hypothesis 4. Wax accumulates, tiny beads exuded, glandular secretions, excretions, accretion. Hypothesis 5. We can be fed into existence. Sliver of silver egg inserted into honey. Then worked hard, hard, hard. Hypothesis 6. It takes 1,000,000 flowers to fill our honey stomachs. A world sucked in, squeezed out. Now, the second poem is called Continuum Hypothesis. And this has to do with questions about infinity. How big is an infinite set? Or more specifically, can one infinity be bigger than another? So think of the number line. It's completely continuous, crammed as full as it can be with numbers. But in the 19th century, the mathematician Georg Cantor discovered 2 different kinds of infinity lying on that line. One kind includes all the numbers we usually think of, all the counting numbers and the negative numbers and 0 and all the fractions in between. And together, these numbers become the rational numbers. But the number line has still more numbers on it. These are the irrationals. Think of pi and all the other non-repeating decimals. Now, all these numbers together, rational, irrational, become the real numbers, and in other words, the whole of the number line, the continuum. The Cantor showed you can't match up the 2 different kinds of infinity, that in fact the second kind is much larger. And the heart of his continuum hypothesis is that there is no other infinity lying on the number line that fits in between these 2. In other words, there's no set whose size is larger than the rational numbers and smaller than the infinity of the real numbers. Well, Cantor kept on trying to prove this hypothesis until the end of his life. And since then, other mathematicians have proved that, in fact, you can't prove it or disprove it. In fact, we just have to live with it. I am fascinated by the idea of the continuum. It seems to speak to something about the connectivity of the universe and how we're all fitted together. And I wonder, what kind of infinities do we live in? Continuum Hypothesis. Not a sliver of distance, no gap from one shade in the skin's spectrum to the next. Not a seam in the fabric, no gap, no dropped stitch in evolution's knit from microbe to me. Not a slice of space, no gap in the sheath of air enclosing earth. Not an empty moment in time, no gap in the flow, every millisecond clasped to the next. And no end to the line of numbers, no gap in their march to infinity. No end to the unfolding lineage of people emerging into their skin generation after generation. And within the number line, no gaps, always another decimal or transcendental flash rising to fill potential. This is the completeness we need from the world. Yet, between infinities, a gap. A stop and start when one number cannot be mapped to another. A gap where the counted continuing becomes less than continuous. Like that gap when one life ends and another enters, a new infinity in a new skin. Or that opening called now, for what isn't here until it is. Thank you.